All right, let's go ahead and get started for today. I don't see Mike here. Daniel, you're here. Can you? Oh, Mitch just joined. Daniel, can you present the first topic?
Yeah, so the linked regression there, which has to do with multiple CA certs and the issues around them. The regression that was introduced in 124.4 and 125.1 has been fixed. Mike and I were talking about doing a more immediate cut to fix the regression, and we just want to clarify it. There's no concerns that we do this to fix it. Just typically there's a wait of 3 to 4 weeks between patch releases, and this would be kind of inside of that.
Does anyone have any concerns?
Doesn't sound like any.
Yeah, didn't hear any. Now, is Mike okay with this? Because he's the release manager, right? So I just want to make sure he's good.
Yeah, he's the one that wanted to bring it up to the meeting, so yeah, I'll let him know.
Okay, cool. That sounds great. Thank you. Keith, should we move to your topic, multi-cluster ambient waypoint? Do you want to present from your machine? Because I know you have a dog. Keith, if you're talking, we can't hear you. At least I cannot. Okay, let's wait for him to get back.
Can you hear me now?
Yes, we can. Do you want to take over the presentation? Because I think you have some slides.
Yes, I do have a doc. Let me.
Yeah, a doc. Okay.
All right, I was completely talking to myself. Thank you for saying something. I would not have known.
Yeah, I saw you were editing on the doc. I'm like, there's no way you're not around. So go.
All right. So how do I even set the context for this? So there is a 273 message long thread in Slack yesterday afternoon/evening, where we were discussing the waypoint routing decision set. This is the wrong doc. Control plane service service over here we go. So routing options, perfect. So basically, we're trying to decide for multi-cluster where we should route traffic with respect to waypoints. Should zTunnel go to the local waypoint first and then go to like pick an endpoint in a remote cluster or a local cluster for that matter? Or should zTunnel make a routing decision based on the information that it knows, and then have the east-west gateway, really the remote waypoint, have the east-west gateway forward to the remote waypoint to do the layer 7 bits and pick a local endpoint. So Mitch put together some principles here, which I think are good to sort of start with for the discussion. So first principle is that global routing decisions must be made at the client location. And conversely, like once traffic lands on an east-west gateway, traffic should be handled in that cluster or fail. This is to prevent looping around multiple clusters, potentially in an infinite loop. Number 2, clients must not have complete knowledge of remote endpoints and pods. This is specifically for multi-network and single network. That is the case, but in this context, talking about multi-network, the clients must not need complete knowledge of remote endpoints and pods. 3 follows from that. Therefore, local routing decisions, as far as decisions reroute traffic to the local cluster, must be made local to the service. And then this 4th one, and this is where a lot of the discussion is happening, is that security policy should always be in control of the service owner, and therefore should be co-located, and by implication probably enforced with the service instance. I have a potential 5th one. which is that the simple case, the common case, should be simple. So that, if this is a common case for users who have the uniform policy and want layer 7 load balancing or failover, that's got to be simple. John, you've got a question or a comment.
Yeah, could you just restate 3 in a different words? I don't understand what it means.
Sure. So decisions.
It's about the particular endpoint selection. So the global routing decision has to be made without knowledge of the individual endpoints behind the service. Otherwise, you have to have global knowledge, right?
Sure.
So that means that once the traffic lands in the remote cluster, some sort of endpoint selection logic has to occur there. That would be how I would.
Oh, okay,
restate
I
that.
see what you mean. Okay, I agree with that then. I think. Okay, thank you. That makes sense. I know you guys know this, but just to throw it out there for people who haven't been following the Slack thread, I agree with 1 through 3, but I don't agree with 4.
Yeah, and what you pointed out, John, yesterday was interesting, which is that 4 is not true in sidecar mode today with multi-cluster, even in a multi-network environment, right? Yeah.
Is it not? Do we apply?
Oh wait, sorry.
the
No,
server-side
hold
part?
up. Well, it depends. Like that's the tricky part. Is that the policy is split in sidecars. So it's true for some of the policies. It's not true for authorization policies specifically. But it is true for all of the other policies, WASM plugins, routes, etc.
That's probably worth a slight detour on its own. So one of the things that we often run into when discussing this is that we sort of adopt gateway API wording when it comes to like consumer, producer, or client-side, server-side policy. Those, and John, people who've been around longer than I have, correct me if I'm wrong, but like those distinctions don't really exist in Istio. Authorization policy is sort of a special case, but by and large, the split of policy in sidecars is, I don't want to say arbitrary. It's arbitrary in the sense of the ecosystem, and so it works for Istio, but it doesn't really fit nicely into these resources are client side, these resources are server side. Is that fair?
It's definitely fair because, like, if you're looking at sidecars, it's true that they're split, but all those exact same policies all apply to ingress, and there it's not split. So the waypoint is much more similar to the existing ingress case, where they're all kind of co-located, and we don't have this semi-arbitrary split between them. So that's why I've been trying to draw an analogy to how ingress works more than how sidecar works, because it's a lot closer parallel, and a lot of the same analogies can be made between waypoints and ingress.
Awesome. Thank you for that clarification. Okay, so now let's head back to the routing options, and we tried to sort of score them according to these principles. If you add this last principle, it's a tie. If you don't add this last principle, as far as like the common case, depending on people's definition of common, then one of the options edges out ahead, which is the option 1. So in this option, zTunnel would do some preliminary weighting based on like sitting to a waypoint. This is all in the case where a service has a waypoint deployed. I should say that. So in this case, waypoints are deployed for a particular service, and you can just take the complex case where the waypoint is deployed in both the local cluster that's sitting the multi-cluster traffic and the remote cluster. John, you also had some diagrams. Feel free to like move them in here as well, because I think some of them it's different views of the same question. So again, in this option, traffic is we decide to send to a remote endpoint would go only through the remote waypoint. So zTunnel deciding whether or not to send traffic off cluster, and it would do so based on the weight of, or basically the capacity being sent for that service slash waypoint that's being sent via WDS. The Z tunnel makes the final like cluster determination, and then the kind of layer 7 outlier detection for picking a particular host would occur on the remote cluster that Z tunnel assumes. One word slash a phrase that I think has helped me discuss this as Mac and I were talking is the idea that Z tunnel is in this context sort of a dumb client. It doesn't see anything about HTTP. And so it's making the determination purely, it's making the cluster determination purely based on layer 4 connection establishments or reset, things like that. I'm going to pause here for a second. Does this make sense to people? Do we understand this option and what's being proposed here?
Does this option requires cluster B always have to deploy the waypoint for the layer 7 policy to be enforced? For instance, I can't deploy the waypoint in cluster A for it to happen. So it puts the requirements on the user to make sure it's having the waypoint deploy at the right cluster. Is that correct?
Yes, essentially. So the best version implementation-wise of this option, I think, is the weighting would apply to the waypoint. We've sort of transitively copied the service capacity and weights to the waypoint capacity and weights per cluster for that service. And so if you didn't have a waypoint in a remote cluster, but you had a waypoint in the local cluster, traffic would always go to the local cluster because there's no waypoint in the remote cluster. There's no weight there.
Okay, so you would basically exclude the cluster B for consideration completely because the fact it didn't have the waypoint and is not going to be able to enforce the policy. Got you.
Exactly. John?
Yeah, so I put a diagram just below this one. I've tried to bring this up a few times on the Slack, and I feel like every time I brought it up, it wasn't that it was said I disagree with it. It was kind of just not considered, it felt like. So I'm not sure if I'm not explaining it well or if people acknowledge the problem and don't think that it's a high priority. So I want to get some concrete next steps on here. My concern with an approach like this is, again, that we're mixing the front end and the back end. So the fact that who is the service we're going to doesn't really have any meaning that we're going to the pods of foo, right? The moment you attach a waypoint to foo, you're saying foo's front end and foo's back end are now decoupled, and the waypoint is the black box in between that maps front end to back end. And by violating that, we get into weird cases. Here I show the line here, shows like the two clusters. I have the same config on both sides. I have waypoints on both sides and a route that says foo goes to bar. And now my client is calling foo. So based on this, I think we would look at the endpoints of foo. This is wrong. I said 33 and 66, but there's one pod on each side, so it would really be 50-50. So if we go local, that's fine. Foo goes to bar, we have a local bar pod, we go to bar. But the problem is when we go to remote, now we hit this foo goes to bar route, and now we try to go to bar locally, but I don't have any pods of bar locally. This seems very odd to me that I'm in a cluster, I'm calling effectively bar, and I'm not able to go there. Like, this is not a global failover. We've actually totally broken the failover and explicitly not sent to the pods that we do have available.
Yeah, so John, you're raising a really good point. And basically, like, more than an infrastructure question, this is about an order of operation question. In the L4 only story, we have a very simple operation. The local Z tunnel is able to make the global routing decision. The remote east-west gateway makes a particular endpoint selection, and everything is very simple because there's no real redirection or munging of an L7, or I mean an L4 request. The question then in that workflow is, where do we introduce L7 routing? particularly because L7 routing can result in the request being handled by a completely different service than it was initially sent to. Is that a good summary of what you said?
It's a great summary. And the reason why I have a problem with this particular issue or with this particular design, it's not so much the fact that sometimes we defer the decision to the remote side. That part's fine. Like the fact that we're crossing this cluster boundary is not the problem. The problem is that we're choosing the weight at which we do that based on the pods of foo. And the pods of foo are not involved in this entire traffic flow. So if it's not valid to look at it, we might as well flip a coin, right? It's not an appropriate thing to base the weight on. If we were to look at, say, for example, the pods of the waypoint and say, 40% local, 60% remote or something, that I think would be appropriate. In practice, that does just mean always go to the local one because we always, or I mean, you can override it, but no one does, do prefer local on the waypoint. But that is something that could be done. But I definitely agree with the problem statement as you laid it out.
Yeah, I think that's a really good point. Is that this is more than like a question of like where the waypoint should be or what waypoint should be routed through. It's really a question that brings up the downside of doing a weighted load balancing algorithm based on the assumed back end of a given front end.
Yeah, so the weighting isn't the only problem as well. Like the weighting is a problem, but as John pointed out, the ultimate L7 routing might result in selection of a service that doesn't exist in the remote cluster. And then we have the question, yet another cluster, do we fail the request because it's on over the multi-cluster hop but still not resolved? It does introduce some problems. Most of these problems are solved, I think, if we do the L7 routing in the client side cluster down to the service selection. That means it's ultimately going to receive this. And we should have the ability then to balance across clusters, but that introduces some other unpleasant side effects, namely that like every client needs a waypoint for every service it's going to call local to the cluster. So even if like I don't plan to run the service in the cluster, I need to run a waypoint for that service in the cluster and have all of the L7 routing rules, all of the policy then in the client cluster and not in the server cluster. And that's a lot of mismatch in my mind.
Mitch, I agreed with you up until the very end. I think the approach that is most viable and doesn't introduce that problem is one such that if there is a local waypoint for the service, you always use it. But if not, then you can use the remote waypoint. And the reasoning then is, I absolutely agree. If we did what you said and have the client or like the server producer have to distribute their policy everywhere and deploy waypoints everywhere, that's terrible. It is a property that we have as sidecars, but it's a really bad property. But I don't think you need to, right? As long as the service producer deploys their waypoints only where they have their service, and we just prefer local ones if they exist or remote ones if not, then we don't really have this problem, right?
So I was going to say something different, but I'll respond to that. I think the trade-off there is that if the remote policy is different, then you don't necessarily execute it. You don't enforce it.
Yes, that is true. That is the trade-off on that one. That
Well,
you don't enforce.
so I think that actually depends, because you could use a like load balancing selection such that like if a local waypoint exists, then you prefer local for routing through that. The question is whether if you hit a local waypoint, it should be able to route traffic off the cluster. I think that is where I specifically have a problem with it, is that if you hit a local waypoint, at that point the traffic should stay within the cluster. And I think it would actually be fine to prefer that path if it exists. It's that if you hit a local waypoint you end up with mismatched policy potentially if you're then routing directly to an endpoint in a remote cluster.
So I think we might have a possible way to solve some of this, which would be that if the local waypoint is going to route to a remote cluster, that it make that decision up front and then apply that remote cluster's policy to the traffic rather than the local cluster's policy to the traffic.
That is basically a nightmare. That's basically a nightmare.
We don't read remote cluster
Yeah.
policy at all.
Yeah. There's just a lot of really bad downsides with that.
It's basically impossible, Mitch, because the routing decision can be based on a random chance or an external service call out, right? Neither of those things are things we can do a dry run.
Yeah, no, that makes sense.
But it would be great. Like that would definitely solve our problems.
So, John, in the case where there is no local waypoint and we route remotely, don't we have the same problem where we don't know if that cluster is actually going to have the backend that the request will ultimately be routed to?
Yeah, so that's a great point. So the interesting thing there is that we don't actually need. Actually, that's a good point. Let's see.
You need all the endpoints for the remote cluster. You can't just get away with the WDS, right? Or sorry, the what do you call split horizon? You need every endpoint.
Well, we know the weights, but it's still the weights of like the service, right? Like
So my take on this is like, yes, you could have the same problem of like if you no local waypoint exists, a waypoint exists in the remote cluster, you route to the remote cluster through the remote waypoint then, and it redirects from foo to bar. And if no endpoints for bar exist, then it should fail. Even if endpoints for bar exist within the local cluster. Because you don't want to try to replicate, or you don't want to try to enforce policy that has not been applied to your local cluster within your local cluster. That would be weird. And at that point, like your failure scope is basically that remote cluster. You should be responsible, like as a owner, if you wrote a policy to redirect from foo to bar, then you should make sure bar is available.
Yeah, Mitch, what you said. Oh, sorry, was someone ahead of me?
I thought Ian was first, but
I was just going to say, like, one of the properties that we want is we don't want to traverse two waypoints. But if waypoints are allowed to select a service that is or a pod that's potentially in a different cluster, as I think John is preferencing there, then assuming there's no local pod that has bar, it could still choose one in a different cluster and succeed. It just can't choose another waypoint to route to. That's what we don't want.
So yeah, what I'm proposing is that once you hit a waypoint, it should not route off cluster at that point.
Also, waypoints would need. I still think you have the problem that waypoints would need to know every endpoint across all clusters to make that happen.
No, they don't need to know every endpoint. They like in either solution, with what Mike is saying, they would only ever know local endpoints because once it lands on a waypoint, the traffic stays local.
Yes.
With what John is proposing, the waypoint L7 routing would be done, which does service selection, but not endpoint selection. So
I was referring to Ian's comment.
Oh, as far as not routing through a waypoint twice. Again, like the waypoint, as far as I'm aware, never does endpoint selection, right? The waypoint in this model is doing service selection, which then defers to another L4 load balancer for endpoint selection.
It's kind of tricky, Mitch, because like let's take the local one as an example. It will have as backends all the local pods or endpoints, but then all of the remote services. So it's neither one or the other. It's actually both, depending on whether they're local or remote.
But what it doesn't need is the remote endpoints, right?
Exactly. Yeah, it does not need the remote endpoints, but it does have the local endpoints. So,
Yeah.
okay, I think we're on the same page. I just wanted to clarify that. If I may go back to something Mitch said about, hey, like, don't we have the problem that I was bringing up for when we go to remote? That's a very good point. I hadn't considered that for some reason. And so now I haven't decided what to think of it, but I have kind of two potential thoughts. One is that I'm just wrong entirely, and maybe it's not such a big deal, and we should acknowledge that this problem between the front end and back end split exists, but move forward anyways and do the back end waiting. Or the other one is kind of that treat the problem as local routing is prioritized. Like in a typical system, if you're in the case where a service is deployed in your own local cluster and in the remote cluster, you're really going to be sending to the local one in the majority of cases, right? And it's only really in the failover cases that you're sending to the other clusters. At which point, if routing isn't as perfect, it's maybe less important because it's so exceptional. And to be like, this issue only really, well, yeah, I guess it comes into play even if there's not a local one. In which case it's not the exceptional case because then you still have to guess kind of which cluster to go to.
Yeah, that's a
Um,
very common scenario too, because there's no requirement
Yeah.
by existed on the local.
Yeah, maybe it is valid to do it then.
So I want to touch on something that I disagree just very slightly and somewhat semantically, but I think it'll become important. I'm not committed to the idea that traffic does not traverse two waypoints. I am committed to the idea that the same L7 logic is not applied twice. So the reason I separate those two out is we're talking about L7 routing, and I think we're coming up with a compelling reason for L7 routing to happen on the client side. L7 auth policy resolution, on the other hand, I think we can make a compelling case that that needs to happen on the server side. Does that make sense?
I agree and disagree. Like I agree that in theory, the concern is not that we hit two waypoints, it's that we apply policies multiple times when we shouldn't have. But I think it may be hard to split what can be applied where. Like in the sidecar, we split it and it kind of makes sense. But like in an ingress or waypoint case, given that it's all muddled together, it seems odd. Like if I only have a route exposing my /public endpoint, is it valid for someone to be able to bypass that? If I have a WASM plugin that does the same, it cannot be bypassed. Like there's all sorts of configurations that are not strictly authorization policy, but that probably should not be bypassable, right?
Yeah.
Even something like a canary rule, like should someone be able to bypass my rule that says 10% to me and 90% to another version, right? Like today, you can't actually enforce that because you say I only accept traffic from the waypoint. And I know the waypoint applied my canary rule.
So this is
And
exactly what I was.
what's this? On in sidecar mode, I believe that you can bypass that. I don't
Oh yeah,
necessarily think that is
definitely
a
can.
good thing.
Yeah. Yes. Yeah, I mean, like that's why I'm trying to use ingress as a better analogy because on ingress you can do the same.
Yeah.
So this is exactly what I was talking to Mike about this morning, and we were sort of talking about a potential future where we have a concept of a client side waypoint or some client side thing. Because in my mind, when we talk about splitting, you've got two options. You've got make the user deploy a client sidecar, which isn't great, or you introduce something to do this client side routing. And the multi-cluster case, I think the thing that you really want is that you want to be able to say in some way that this policy should be applied when talking to this service that exists in a different cluster. Whereas the policy you're at today is policy that should apply when something is talking to me generally. Does that statement resonate with anybody, or am I missing something basic there?
I think that makes sense.
Okay, so if theoretically, like if we could do that in theory, do we feel like that would solve some of this? Where essentially you'd be able to go and forget the latency and cost here, but for a second, but like in theory, you'd be able to go Z tunnel client waypoint client thing, L7 client. I'll just call it that. Like Z tunnel L7 client applies L7 policy to off cluster east-west gateway layer 7 server waypoint into the backend. Do we feel like that would solve these problems that we're talking about?
It solves these problems. Well, I'm not even sure it solves these problems. So like, let's say you do the layer 7 routing on the client side that leads you to select a particular service. Then you're going to land on the destination cluster and do a second set of layer 7 routing.
That's
that
true.
Theoretically expects, or respects like, progressive rollouts like John was talking about, or local weighting.
Yeah. So you need like an override. You would need some sort of override idea where the producer waypoint would defer to the I'm going to use producer. The server waypoint would defer to whatever the L7 clients said for routing.
I don't think that's desirable. I think that's leaking too much across the cluster boundary.
I agree. Yep. That's why I asked. Stop me so you can stop me before I go too far ahead.
So I think that the good thing about like if you have a specific way of doing like a smart client of some sort, then what you need to do is rather than having it attempt to automatically apply producer side policy, you can somehow write client side policy differently. So like that could be the way Gamma is currently, it's you write an HTTP route with a parent ref for a service that is outside of your namespace. You could also do something with like service entry or something like that potentially. Basically, a way to make it clear that this is something that is intended to be client side policy. Rather than trying to apply the like ingress, the like waypoint producer policy at the client. So and by splitting it up clearly like that, you avoid kind of the need to nuance between what parts am I doing, what parts am I not doing, because that smart client, if it selects a destination within the local cluster, then it goes to the producer, the existing waypoint, at which point the policy exists, it's applied. If it routes to the remote cluster, then it goes to the remote cluster's waypoint, and that policy is applied. So that you're not risking a double application of the same policy. You might have two waypoints, but it would be different policies with a kind of a clear separation.
So that's what I was trying to suggest, but I think you still run into the same problem of you end up having to make the server side waypoint defer to the decisions of that first waypoint, because you can have like routing policy, for example, declared on both the server and the client, and one has to win. Otherwise, you do double apply.
So it's not deferring. It's that if you're doing a redirect in a client side rule of some sort, then that redirect is happening locally. So if you're redirecting from foo to bar locally, then it will route. It'll
The bar. Oh, fair enough. Yeah, that's right. That's right. That's right.
And if there's a waypoint for bar locally, then it resolves. If there's pause for bar locally, that resolves locally.
Gotcha. That's good clarification.
And if that redirect is only happening on the server side through an existing like waypoint regular, then yes, it's possible that it could target foo go across the cluster boundary, and if there's a rule written that redirects it to bar and there's no pods of bar in that cluster, then it fails. I think that is expected behavior.
Yeah, I would agree with that. So that's, in my mind, that's a potential area to explore in the future. I guess the reason I bring this up to begin with is, like, do we feel like that actually solves these problems? And if it doesn't, then like we can move on. But if it does, then maybe what we do is, like, it seems like 1 and 2 have similar problems at their core, if I understood John and Mitch's back and forth correctly. But if we could introduce a smarter client at L7 in the future, maybe we pick the architecture that allows us, that would be more compatible with that. Does that make sense? Am I off base there?
I don't
John,
think
go
you're
ahead.
off base, but one slightly off topic. I mean, not off topic, but off of that note. I am starting to walk back my stance against this back end waiting to pick the front end. Thanks to Mitch. If that opens things up in a different way. The thing I think is important though is in this scenario, like I'm talking about the diagram on the screen here, it's important how we decide which waypoint to hit and then what we do with it. So I think Mike said, for instance, a waypoint can never go cross cluster, for example. I think might end up in a weird scenario, because what I would expect typically is that a user has a configuration that says prefer local, right? Which would mean that as long as there's a pod that's local, then we're always going to hit the local one. And then we're never going to... so in the case where I have, let's say I'm actually coming from the other cluster, where I have no bars, I'm going to always send to my local waypoint because of my traffic distribution policy tells me to do that. But then with the rule that says that a waypoint can never call another cluster, I'm just going to fail. And I think that doesn't align well with users' expectations. I think they expect to be able to fail over there. If we were to instead say that a waypoint can call another cluster, as long as it has not traversed, like if we change the rule to be you can only cross the east-west gateway once, rather than you can't cross the cluster at all from a waypoint, then I think you'd get a better behavior, because what would happen is you'd hit the local waypoint and then you'd be able to spill over into the other cluster. I guess the issue then with, from Mike's point of view, probably is that then you don't have the local policy enforced. So
Yeah.
maybe that's a concern there.
Yeah.
I guess there's just, I think we have a fundamental just different weighting of the importance of hitting the local policy versus applying better load distribution. It would maybe be a way to sum it up.
Yeah. Right? Yes. I think that's an accurate diagnosis there. So what I'm wondering about is with like the prefer local case, if the waypoint fails to connect to a local back end, how bad is it if, like, I'm assuming that because of like H1 proxy protocol, like the Z tunnel gets potentially, if like there's fuzzy local backends and waypoint can only route locally, the Z tunnel gets some kind of L4 signal that this TCP connection failed. At that point, if we have some kind of
so what Z
outlier
tunnel can decide
detection,
on
like
today is just
what can it do?
the health. It just has the health of the endpoint. So I mean, in multi-cluster we don't have anything, but presumably we'll get some sort of number of healthy endpoints in the remote cluster, and that's all it has. We could add an L4 more dynamic outlier detection type thing into Z tunnel. We don't have that today, but it's reasonable.
Okay.
But that's not available right now. And not all failures are, like in this case, we're showing really obvious ones, like there's 0 endpoints. And so, the connection fails and we can do outlier detection. Obviously, some of the things that Envoy does is like, I'm getting 503s, too many 503s. I'm getting 55% 503s and I only wanted, less than 10% or whatever.
Yeah.
So we would lose that for sure.
Yeah, so I think that that's actually a like reasonable trade-off of having a dumb client is you don't get that like really smart like L7 fine-grained outlier detection. But if we have some kind of basic outlier detection for like TCP connection failure, then eject that temporarily and then allow that to fail over off cluster potentially. Maybe that's workable. It's a new thing to build, but I think it could work. I was talking about this with Keith earlier today.
So then what would you do if you did want L7 failover or L7 outlier detection?
That would be a feature gap of some sort. We would need to design something, a like smart client of some sort. That could be sidecar interop with ambient to deploy sidecar as client. It could be some kind of floating like client waypoint you can write client policy for. There's a few different ways to approach it.
So we wouldn't
Yeah,
be,
but just-
we wouldn't be making it impossible. We would just be saying Z tunnel doesn't have that by default.
Yes. Yes.
Yeah, I think that's
Exactly.
required. Like we've got to be able to ship multi-cluster Z tunnel without the L7 outlier detection, but we also need a path towards adding L7 outlier detection. Does that make sense?
Yep. And that's where I brought up the smart client idea to see if, like, at a first blush, does that feel like that's something that we could do and that would solve these problems? Because if we feel like there is a potential path there, then I'm more okay with a feature gap today if we can invest more time into getting something into filling that gap in the future.
Keith, can you recap the smart client? Because I'm not sure I understand the title there.
The idea is that you'd have a L7 client that would be smart, and that would give you your layer 7 outlier detection in the future. So that's like a layer 7 client waypoint only.
Gotcha.
That you, to Mike's point, would program differently and distinctly from an API perspective, where you just have that client-side policy.
Okay, and that would not apply the normal like service HTTP routes, like auth policy, etc. It's just going to be doing the various outlier detection things.
To some extent, it would need to. I think you would need some of those just so you know you're doing outlier detection on the correct things. Because again, you don't want to mix up your front end and back end. So like this layer 7 client, if you've got that, you'd want that to be able to know what your back end is and do outlier detection based on that. Otherwise, you're no better than the dumb Z tunnel client, right?
No, you're better. Like, I don't think the whole point of outlier detection is that you don't need to know the ultimate back end. You don't need to know where the final resting place of your traffic is. What you need to know is that when you send traffic to this URL, 5% of it is coming back 503 for some reason. And therefore, maybe we should shift to other URLs that are similar. Does that make sense?
That is not my understanding of what outlier detection is. Outlier detection, according to to my understanding, is an injection of particular hosts / endpoints from a load balancing pool. And so it's specifically when you get an amount of 500 from a specific host or a specific endpoint, you eject that endpoint from the load balancing pool and go to other endpoints.
Right. So let's say we have service foo that is represented by 3 remote clusters and we're in a client cluster.
Mm-hmm.
We're sending traffic to it and we notice, so we've got a load balancing pool with 3 entries in it. They're each east-west gateways. We're sending traffic to service foo and we notice that when we send it to cluster A, we tend to get 503s back. We're going to eject cluster A from that load balancing pool, right?
If I may, I think you guys are getting mixed up because you guys are both right, I think, as I understand, right? In that, yes, outlier detection is a property of the endpoint, but we happen to put service addresses into the endpoints, not pods, for the case of remote clusters.
Right.
Maybe that is where the disconnect is.
Okay, so so the service URL is, so where do you go in? Okay, so instances of those. Okay, guys, got it. So the load balancing pool is a set of services, not a bunch of not backend pods.
Well, an outlier detection on pods can still happen, but it happens from the perspective of the remote waypoint.
Right.
The remote
Waypoint to
says,
cluster.
I've got
Right.
these 10 pods, and for whatever reason, this one is shit, so I'm kicking it out, right?
Okay. Yes, that's right. That's right. Okay. Because we have a particular workload for resource gateway. That's true. So you eject that entire cluster essentially. So you still get outlier detection from, yeah, you're right. You are better because you've got the HTTP outlier detection for when you're talking to a specific cluster, and you're able to fail over to a different cluster. And cluster is just like a abstraction for region or whatever else, right? Okay. So yes, you are strictly better.
So I want to make sure that I understand the solution that we're sort of spiraling around, maybe, or zeroing in on. It sounds like remote traffic will never traverse a local or a local waypoint, but will traverse the remote waypoint always. And therefore, all the remote L7 routing policy, etc., gets applied. And then eventually we'll find some way to do L7 outlier detection at the service level in the client side. John, is that, I think I've heard it from Mike and Keith. Is that what you're thinking, John?
It's not what I'm thinking. Like, it's something I could live with. I think it's an acceptable, it's a valid solution. We've come up with, myself included, a lot of solutions that I think are just not viable. This is one that's viable. I personally think it's better to have a better load distribution than to have the construct that you always use the local waypoint policies, just because of my experience with users and how they deploy their infrastructure. I don't think the lack of policy localness is a big deal. And I worry that with this approach, what will happen is that you'll pretty much end up always sending traffic locally because we don't have sufficient knowledge to know when to send remotely. And so we'll kind of always prefer the local one, always go there, and then things would kind of get wonky because that waypoint can never send across cluster. But it is plausible for sure. I just think it might be, at the very least, I think someone coming from a sidecar world will be very confused that the dumb proxy is deciding which cluster to go through and not the smart proxy. I don't think we should wait too much on what sidecar users are used to because we've already violated a lot of those expectations, but that will come up for sure as a mismatched expectation just because it works quite a bit differently.
Yeah.
So John, you're saying that we would send to the local, what are you saying we send to the local waypoint? I missed that in the various back and forths.
Yeah, so my suggestion would be that we allow the local waypoint to talk to remote endpoints, basically. So that way, what's going to happen typically is you're always going to send. Okay, let me just walk through like a full life of request. That'll be easier. So I am ztunnel. I get a request to foo. I don't look at the endpoints of foo. I don't do anything like that. I just know that foo has a waypoint and it has a waypoint locally. So I use that waypoint. There could be 0 endpoints locally. That's fine. We'll still use the waypoint. Now, food makes the decision. It can say, I'll send locally or I'll send remotely. If there was no local waypoint, then we'd go and pick the remote waypoint, and we can get into how we pick that. That is kind of, all sorts of decisions that don't really matter that much. I mean, they matter, but it's not like, doesn't define the choices. Finally, then the gap, though, is that you don't always go through the remote waypoint. So there's potential policy mismatch of expectations. So it's really a trade-off of, do you want better load distribution, that sort of thing, or do you want the property that your policy is applied by your local waypoint?
I think it comes down to a question of how much we're leaning on namespace sameness. If we want to lean really heavily on namespace sameness, then having those decisions made by the local waypoint whenever possible makes sense. And we can tell customers that like the ideal environment is a set of completely identical clusters.
I remember we had a survey on that. If I remember correctly, there was a good percentage of user, I think it's an equal percentage of user who said you can't assume like the the cluster 1 and cluster 2 is entirely the same, like the
Yeah.
same namespace. So I think the percentage significance is enough that we can't ignore it.
Yeah,
Lynn, but
I've heard that
there's a
enough
big
users-
difference.
Go ahead, John.
Sorry, sorry, I didn't mean to cut you off. I think there's a big difference, Lynn, of saying that namespaces, like we already have the concept that service A means the same thing in 2 namespaces. So if a user is saying that they are not okay with that, all this discussion doesn't matter because our entire identity model and everything we do in Istio is broken. If a user is
Yeah.
saying that in some clusters I have service A in this namespace and some I have service B, that's totally fine. We support that fully with both proposals. The only issue with the policy is if I deploy product page in both clusters, but I only apply an authorization policy in one cluster, and I expect that to behave in a certain way. That's something I think is very rare. In my experience, ignoring like a rollout or a mistake, typically what happens is the user has a Helm chart or an Argo policy or whatever, and they go blast that to all the clusters.
But I don't think we can ignore rollouts. Like transitional states are what always bite Istio. And particularly if you imagine like a global rollout of a new service where you're progressively rolling out this new service, new version of a service. It's got a subset, which is also a service. And you're doing weighted routing in one cluster to progressively move traffic to that new version. Any traffic coming from multi-cluster is not going to respect those progressive rollout rules, right? And that's an expected state because we don't want to be telling our customers like all your rollouts have to be global.
Yeah, that's fine.
I don't know
So
how
you
big of a
just,
problem that is. Maybe that's not the
it-
end of the world. I don't know.
No, I think that's fine. So in that case, you just apply the policy to the specific cluster you want the rollout to happen, right?
Well, so that's basically the core challenge here is like if you I'm in cluster B, I am rolling out service V2. I deploy some service V2, I deploy a service V2 with some pods, and I write a redirect from service to service V2. That means that if we're going with the model I'm proposing, any traffic internal to the cluster hits the local waypoint, sees the rule, gets translated, goes to service V2. Remote traffic, if it is routing through the destination waypoint, it will make sure that it follows those same rules and will go to service V2. And then you can safely turn down the V1 service, the old pods. You can get rid of those because you know that all traffic will always be going to that service V2. If you're routing always through the local waypoint and applying that policy and potentially routing to remote destinations endpoints, skipping a waypoint if it exists in the remote cluster. There's 2 sides to the scenario, and both of them are bad. For requests originating in a different cluster, if there's a waypoint that exists, it applies some waypoint logic in that local waypoint, and then when it gets to the remote cluster, it's potentially still sending to that original service, even though you've been trying to migrate your users to that new V2. If you're sending from the service where you have this routing rule applied and you have your new V2 service, and you hit that local waypoint and it's allowed to select remote destinations, then like you're applying those routing rules and you're potentially trying to send traffic to a V2 service that probably doesn't exist off the cluster. I don't think that's as bad because you don't have any other path points. But it's still kind of weird.
Okay. Oh, Ian's got his hand up. I'm sorry.
Yeah, so I think there's like kind of 2 scenarios there. In one, your local cluster has a waypoint that represents service, and it's probably trying to fail over now. Something's wrong with that cluster. That connection was going to fail if you kept it local. It tries to fail over. Maybe service 1 exists in the other cluster. Maybe it doesn't. And in the end, the traffic still fails. In the other scenario, there's no local waypoint because the service isn't available in that cluster at all, in which case it will just like consume the service correctly in the remote cluster.
Yeah, so I think that's kind of a valid question. This goes back to John's point, is that like, is it valid for a waypoint to try to fail over to a remote destination, or is that it feels like we're like intermixing like ingress style failover with like client failover, and we're trying to do like client failover from the client cluster through a thing that is designed for as like a like producer style intermediary.
So can we just tell user to deploy the route configuration on the producer side?
Not if you're going to have go to the local waypoint.
That's true. Okay.
I still think that maybe
Actually,
there's
let-
some potential for pulling config from another cluster. If you're going to route remotely, pulling at least like HTTP routes from the other cluster and applying those.
Which
on the
other
client
cluster?
side.
It gets
Which other
The
bad.
cluster?
destination cluster.
How do you
will
know that at
promise
control
you
plane
that-
time?
Yeah, I will promise you that gets really bad really fast and has very nasty replication and state consistency bugs.
Yeah, that's fair.
Ian, and then we should probably try to wrap up soon.
So actually, when I was thinking through this, I think I had a flaw in my logic. The local waypoint is going to do some sort of selection, and it's going to say, okay, service reroutes to service V1. That's my policy. I don't have a service V2. Now it's going to go out and look for places where service V1 is running and try to send to those. So if you have some region where you've rolled out service V2 and scaled down service V1 locally, it should never try to route there in the first place. It would go to some east-west gateway that advertises service V1, and that east-west gateway would resolve it to a pod. Yeah?
I think so.
And only if
Honestly,
you
my
use,
brain is kind of cooked.
Yeah,
Yeah.
I assume only if you use this new Kubernetes gateway API style, right? So you actually have service V1 and V2. If you use virtual service, I don't think you have that intelligence. It's one service.
Right. So HTTP route, you have to have a local version that the service is referred to in backend ref. And virtual service, you do not.
It also depends a lot about like how we actually do that endpoint selection. Like, because it's possible that even if you have no pods left for that V1 service, you might still have a waypoint there for the purpose of redirecting old traffic within that cluster. So if we're selecting based on like the presence of a waypoint in a cluster means that it's available, but if we skip that waypoint, then it's invalid.
Okay, I'm gonna drop. I'm gonna try to write up like a brief summary of what we've talked about in terms of all the compelling reasons to do L7 on the client side, and then all the compelling reasons to do L7 on the server side, and we'll have to hit this again next week, I think.
Yeah, that sounds
Or on
good.
Monday. We have a TOC meeting on Monday, right?
That's true.
Yes, let's do that. Oh,
And that would be
excuse me.
good because
I'll be
I'd
on
love to hear what
vacation,
Louis
but
has to
you
say
guys
on
can-
this, and
yeah.
Costin, frankly.
That's good
Yeah.
point. Yeah.
Maybe
Yeah,
LLMs will
Louis
save
out
us
of
and give
office
us.
this week, by the way. So I'll fill him in on. I'll catch him up to speed on some of this because I talked to him a lot about this. So I have a
Do we think he'll be
multi-cluster
back on Monday?
shared vernacular. I think he's in London and flying. He'll be back Monday for sure. Yeah.
Okay.
Yeah,
Okay.
he's at QCon this week, so
I think he
but
flies
I'll
back
be
like
on
today or
He
vacation
told me
next
you guys
Monday.
keep him working hard.
Well, he wants to be in Europe. Who doesn't want to be there longer?
I expect that I'm largely representing Costin's position on this too.
Okay.
Very cool.
That wouldn't surprise me. All right. Thank you, everybody, for continuing to be patient with me and talking about the same thing week after week. But I think we're inching closer to a decision point here. So really appreciate everybody's thoughts.
All right.
Thanks
Thanks
for the discussion.
everybody. Bye.
Take care.
Bye,
Cheers.
folks.